right, next up, we're just going to briefly look at some types of reactions. Really learning about chemical reactions is something that's kind of done in the real world. So when you go into lab, you learn about chemical reactions there. And then as you go further in the class, interact with the material and whatnot, you'll just learn more and more and more. So we're just going to take a brief overview of certain types of chemical reactions. So the first type that we're going to look at is precipitation reactions. And precipitation reactions are something that forms a precipitate, which we can abbreviate to PPT. So that doesn't stand for PowerPoint anymore. Now it stands for precipitation. And a precipitate is just a solid. Right, so precipitation reaction is something that forms a solid, a precipitate. So for example, if you have potassium iodide, that's aqueous, plus lead nitrate, which is also aqueous, to form lead iodide, which is also aqueous, or my bad, which is now a solid, and then we'll also form some potassium nitrate, which is aqueous. So notice that we formed a solid here. So this is an example of a precipitation reaction. We're taking two compounds that are dissolved in water, and then we're mixing them together, and then we form a solid, right? And so here's our little picture of that and what's going on, right? In one solution, you have the Ki. In the other one, you have the potassium nitrate. Note that they're both clear, colorless solutions. And then when you mix them together, you see a solid start to form, which will eventually settle down on that bottom. And that solid is your lead iodide. Notice, how do we know that lead iodide is going to be a solid? We find I- right there, and it becomes insoluble when combined with lead. So let's take a look at another form of this question. So what happens when I mix potassium iodide and sodium chloride? Will we form any kind of solid? And so the way that we want to do this is we want to mix and match all of our anions and cations to see if we can find a combination where they'll become insoluble. So we'll take one of the cations and then mix it with the other anion, so KCl, and then we'll take this anion and mix it with this cation, plus NaI. And then we'll take a look at whether any of these are going to form precipitates. So we have potassium in that first equation. Potassium is right there, and there are no exceptions. That's always soluble. And then the same thing with sodium. That's always soluble. So in this case, we have aqueous and aqueous, and there'll be no precipitate formed. All right, because we didn't form a combination that became insoluble. Let's take a look at another example. So here we're going to have barium nitrate plus sodium sulfate. And again, what we're going to do is mix and match the cations and the anions. So we'll take this barium, which is the cation, and mix it with the anion to form barium sulfate. And then we'll take this nitrate and mix it with the sodium to form sodium nitrate. Notice that in my equations, the cation always comes first. And then we take a look at whether any of these are going to be forming precipitates. So let's take a look at barium sulfate here. So if I take a look at my ions, I don't see barium anywhere, but I do see sulfate. It's in the mostly soluble side, except when paired with calcium, strontium, lead, or barium, right? So we can see that's insoluble when paired with barium. So this indeed is a solid, and this is your precipitate that will form. And then you can check the other compound as well, sodium nitrate. Sodium is right there. It's always soluble. There are no exceptions. So that will stay as an aqueous solution. So this will indeed form a precipitation reaction. Note that overall my equation is not yet balanced. You can balance it on your own.